Okay, good afternoon, everyone. Today we're going to continue our discussion on returns, log returns, simple returns, making use of an example and then applying it directly to stock prices using some packages in R. So let's have a quick review. We learned that simple returns is simply computed by getting the quotient of your current price divided by the previous price minus 1. So this is for a single asset, single return, single period. We can also compute for the cumulative returns for simple returns. And the formula to compute for the cumulative returns, when I say cumulative, you join all, you combine the returns for several periods. Okay, and the formula we learned is equal to the product of the product of 1 plus R, where your R ranges from t is equal to 1 to t is equal to the total number of periods. Note, t is the number of periods, not number of prices. We learned before that if there are 20 prices, then there will be 19 periods. Okay, and then minus 1. So this is the formula for a multi-period cumulative returns. Okay, then we also learned about the log returns class. Simple single period log returns, which is just the log of p sub t over p sub t minus 1. And by definition, we discussed before that this one, log of p sub t over p sub t minus 1 is simply equal to your log of p sub t minus log of p sub t minus 1. That's the definition of logarithms. And we also learned that for very small returns, your log returns is approximately equal to your simple returns. For multi-period log returns, okay, the formula is the additive. It's additive of all the log returns. That's why in finance, it's preferred to use log returns. Aside from the fact that it's additive, also the distribution of your returns, because log returns can range from negative infinity to positive infinity. And on the other hand, simple returns can range from negative 100% up to positive infinity. Okay, so log returns are preferred because of its distribution. And then we said that it's easy to convert your log returns into simple returns. Just this formula, r sub t is equal to e to the r sub t minus 1. Where r sub t is either your simple, either your daily log returns or your cumulative returns. And vice versa, mali ito formula to convert, this should be simple returns to log returns. And we know that the formula is simply equal to r sub t is equal to log. Sorry. Log of, oops. Kaya pala, I'm using the okay. All right, so this is what we learned before. Okay, and we had several examples. Now let's have one last example. And let's load first tidyverse. Check first in your packages if you have tidyverse, please. Go to packages and then type tidyverse. Kindly chat, please, if you have or not. All right, if you don't have class, just make sure that you install it. Install. I'd like to install two things. Number one, tidyverse. I will not I will not install this anymore because I have it. So tidyverse and then install the dependencies and then install. And then once you have installed it, click require. So your tidyverse should appear here already in your packages and then require or library. Okay. So what happens when you load tidyverse? I'll wait for you to inform me, class, if you have installed and loaded tidyverse, please. So have you installed tidyverse and have you checked tidyverse here? You should be seeing this. I'll just explain what this means.
Kainin natin sa
Okay, class? Kindly please paki-chat kung meron na kayong tidyverse. Okay, thank you. The others who haven't confirmed yet, please, kindly. Okay. All right. I hope everybody has tidyverse already. You'll be able to check that if you go to packages and then click it, which is equivalent to using library or require there. When you load tidyverse, you'll notice that it gives this message unless you suppress this message. So you have dplyr for cats. This is for categorical variables, ggplot for data visualization, lubridate for use in dates. If you watch the videos, class, that I required you to watch, then you would have met this lubridate. Per, read R, string R, table. Table is a special type of data frame. We're going to use this, and tidyr. So tidyverse is a family of packages, so that when you load tidyverse, it will also automatically load this. Load these other packages. Okay, and then what does this tell us? You have here conflicts. This tells us that dplyr has a function called filter, and it will mask the filter function coming from the stats package. So if you have dplyr installed, loaded, which is in this case, okay, if you check, for example, dplyr, although we did not load this individually, it's already checked because once you load tidyverse, it will automatically load the other packages also. And the filter function from dplyr, if you're going to use the filter function, it will follow the syntax of dplyr instead of stats. Now, check, class, if you have stats installed. Kindly check, please, stats. Is it loaded, class? Is it checked here? Kindly please chat yes or yes. I'm expecting a yes from you. Okay. Okay. Thank you, class. Yes, you're correct. Because stats comes pre-packaged with R. Although we did not load it, class, it's automatically loaded. So the next time you open R Studio, go to packages and check stats, and you'll see that it is checked, which means it is loaded, even if we didn't use the function library or require. Okay. So tidyverse has already been loaded. Now let's do some. Let's create an object called prices. These are hypothetical prices: 100, 102, 103, etc. So please type this. There are 12, 12 prices there. So let's just, this is just a hypothetical stock price for the past 12 days. And then we create an object called prices, okay, where we are concatenating all these values. And then let's also create another object called dates, where we are pasting the word day, comma. Paste 0 means that you concatenate, you combine day, and then comma. This one is numerical 1 up to length in prices. If you check length in prices, class, the function length is used for vectors length prices. So it will tell us how big or how many observations your data has. So length prices means there are 12 observations. Okay, so we have now created this object prices and dates. Okay, tell me, class, what's the result of prices? If I print this prices here, Control Enter, you notice that I have these objects. Now, where is prices located? Is it in data or is it in values in your environment? Kindly check, please, and please chat if you see prices data or values. Data or values, class? Okay, waiting for your response, class. Where do you find prices in your environment? Hello, class. Hello. Check your environment. If you have created prices, class, where is it here? Is it in values or is it in data? Come on, class. Values, okay. How about the others? Values. I'm getting only 3 responses. Okay, so thank you, class. You're correct. You can find it in values. Okay, so what's the difference between data and values? When an object is stored in data, that simply means that it's either a list, an array, or a data frame. When a data is stored in values, it means that it's a what class? It's a vector. Okay. So I hope you have watched the video. Again, I keep on reminding you, a vector is an object that contains only the one type of element, one type of data. So if it's all numbers, then it's all numbers. It can be all letters. It can be all logical values, etc. Okay, so this is a vector. And the same with pastes, with the dates object. So we're using the paste function, day, and then comma, which means that it will paste these two, day and 1 up to length prices. So length prices is up to 12, so that's day 1, day 2, day 3. Okay, if I run this and then type dates, so you can see we have day 1, day 2, up to day 12 because there are prices has a length of 12. I can remove the space here. Okay, and if I print this again, you notice that the space has been removed. Okay, I'll just I'll just revert back to the original. Okay, now so we have the prices and dates. Dates is also the vector, so you'll find it only under values here. Okay, under values. It's a character vector. You're combining text and number. That will be a character vector. All right. So let's now create a data frame. We can use a special type of data frame called table. Okay. You notice this package was also installed. So the package table has this object, has this function called table. And then a table is used to create a data frame. So here we have date is equal to dates. Date here will act as the name of the variable. So we're creating now a data frame, and you know a data frame is a rectangular matrix containing rows and columns. Okay, the columns have their own names, variable names, and then the rows may also be given names, but they are unique, unique names. All right, and then we're creating also this object, this a column named price, and it contains price. So if we print this class, run this, so you can see here day 1 up to day 12, and then the prices. So we were able now to create a data frame. Okay, so if you check price data is under price data is under here. It's under data. Okay. All right. So let's now calculate returns based on this data that we have. So if you recall, simple returns, okay, simple returns is simply the price at time t divided by the price at time t minus 1. Okay, now let's study this first. We're creating this object, simple returns. This is your assignment operator, and then you have prices, -1. What does the bracket do, class? The bracket is used for subsetting. So if you have an object and then you'd like to get a portion of the object, then what you do is to subset. Okay, so this one indicates that it's a subset. Now, what are we subsetting? This vector prices. Okay, so when you subset a vector, the result will also be a vector. Okay, so prices and then -1. What does that mean, class? Prices and then -1. Let me print prices again here, prices. Okay, let me put it in parentheses so that it will automatically print. When you put an object in parentheses, it not only creates it, it also prints it there. So this is our prices object, right? 12 stock prices. Now, when we get a subset of that, bracket, -1. -1 means negative stands for do not include, right? So it means that it's all this object, this vector prices, but do not include the first one. So once again, I'm going to print this, open parentheses, control enter. So what do we have here, class? We have an object prices containing 102 up to 107, which means that the first element was removed, right? -1. Now, what if I want to remove the last element? So in order to remove the last element, what we do is you use this. Okay, here, plus. So this is the first one. Okay, remember this is also a vector that excludes the first element. Now, we also subset prices, but this time negative. So we're removing something. Okay, so if I run length prices, what does this give us? The length function is used to determine how many elements are there in a vector. So 12, no? 12. Tapos magma-minus ako dito. That means I'm going to exclude number 12. Okay, so let me do that. I'll copy this. Here, Control C, Control V. Okay, so what does this mean? I'm going to print this. It means, oh, sorry, I missed the brackets. I'm getting the prices, subset it, and exclude number 12. So that means it will only include from 1 to 11. And I'm going to print this, and there you go. You can see that the the last one, okay, this one, 107, is not included. Okay, now take a look at the function, class. So it is this one. Prices, -1. So what's that? Ito yon, class, this one. Right? Prices -1 will exclude 107. And then divided by prices -12. So that one will be this one. Right? So what will happen, class? Prices -1 is this one. This one, class. Okay? And then you'll divide it by prices negative length, which is this one. So you have a vector. You can only divide vectors if they have the same lengths. So this one has a length of 11. This one also has a length of, sorry, yeah, 11 because we removed one, right? This one also has 11 because we removed one. So we can divide them, okay? And then it will be a pairwise division. So it's prices -1, this one, here, sorry, here, this one, divided by prices -12, this one. So what happens now? Prices -1, 102 divided by 100, and then -1. And then 103 divided by 102, -1. And then lastly, 107 divided by 106, -1. So what technically is happening? Technically, class, what's happening is, diba? 102 divided by 100, -1. 103 divided by 102, -1. 107 divided by 106, -1. So you're technically getting the simple returns, right? Of each of the elements of your vector. So a complete vector of 11 objects, and then a complete vector, and then we minus, divided by a complete vector also of 11 observations, and then -1. So that's equivalent to getting the returns. All right, so let's run this class. Simple returns. And let me check here, simple returns class, simple returns. Let's print this. I'm going to print this, Control Enter, and there you go, class. And how many elements are there? 11 only. 11. So this is actually P sub t over P sub t minus 1. This is also actually P sub t over P sub t minus 1. So these are your simple returns for the past 11 periods. Notice, class, that there are 12 prices, but 11 periods. So similarly, class, let's create a data frame. simple returns data frame, and then we're going to use the table function, and then let's create this variable period is equal to paste 0 again, and then let's use the word period. I'm not going to use day, okay, or oh yeah, day. It's best to use period. Period 1, okay, until how many periods do you have? 11, right? You have 12 prices but 11 periods, so up to the length of simple returns. Take note, simple returns has this one, right? Has 11 periods. Okay. And then the second one, we create another variable, simple returns, and then it's equal to simple returns. Okay, so we have period 1 up to period 11, and then the other column is simple returns. Okay, so let's now run this, and you can now see this is now our data frame. We just combined period 1 and simple returns. So we have 11 periods all in all. Okay, let me pause for a while and allow you to catch up. May I have your confirmation if you're able to follow? Kung yes, or in case you have any questions, please feel free to ask your question. Okay, thank you, Ariel, Adrian. So let's wait for the others to give their feedback. Okay, good. Thank you so much. Pero tatatlo lang. Let's give your classmates a few more seconds and then we'll proceed. All right. Okay, thank you. Okay, so let's now go to this time to log returns. Okay, thank you, everyone. Okay, now let's first understand the formula. By way of review, we know that log returns is simply, okay, di ba ang log returns is simply equal to your log of the price at time t minus divided by price at time t minus 1. Okay, log of p sub t over p sub t minus 1. By definition, this one is equal to log of p sub t minus log p sub t minus 1. Okay, in other words, the log of a quotient is equal to the differences, the log of each, the differences of the logs of each, of the numerator and the denominator. So ito yung class. So may function sa ano, may function sa R, which we can, well, actually it's two functions, no? It's two functions. So if we're going to use the log, if we're going to get the logarithms class, we have to get the log first of each of the values. So kunyari ito 100, di ba? 102, yung ano natin prices, 103, etc. What we have to do is to get the log of this first. Log of this, log of this, log of this, log of all the prices. and then perform this. Since naka-log na to mga to, no? Then kukunin natin log of 102 minus log of 101. And log of 103 minus log of 102. So that's what we do, class, in getting the log, class. By definition, the log returns. No? Okay, so let me close this, close quickly, and go back to the prices here. I'm going to print prices again. Ito yung prices natin. Prices. Okay, ito yung prices natin. So what we do is to get the log of each of this, and then i-difference natin. Once we get the log of this class, i-difference natin log of 102 minus log of 100 until log of 107 minus log of 106. That's equivalent to getting the log. So how do we do this, class? So first, kunin muna natin ng log ng prices. No? That's the first step. Let's get the log of each of the elements here. So if I get the log of prices, that's what we'll get, class. Log of 100, log of 102, etc. And then once I get the log, so mga log na to, di ba? Okay, we can now get the difference. Why? Kasi remember, class, ang log returns is the log of p sub t divided by p sub t minus 1, which is equal to log of t, p sub t minus log of p sub t minus 1. So after getting the log, kailangan ima-minus natin. And the way to go about it is get the difference. Yung diff function, class, gets the difference, later value minus your earlier value, later value minus your earlier value, later value minus earlier value. Okay. When we get the log, class, of prices has 12 elements, no? So ang lalabas nito, 12 din to. Kasi kukunin natin log ng bawat isa. Now, however, when we get the difference, class, okay, magma-minus tayo. 4.62 minus 4.6. 4.63 minus 4.62. 4.67 minus 4.66. Isa-isa yan. However, ito, class, yung 4.60, wala siyang prior value. Kaya wala tayong makukuhang difference. No? So what will happen is that sa differencing, there will be 11 observations. Okay, so let's do that. No? Difference ng log ng prices. So, ang gagawin nito, class, kukunin muna yung log, tapos kukunin yung difference. And this is equal to the log returns. Class, Control Enter. There. And how many objects do we have? I-round mo lang muna natin, class. Can round this round, open parentheses, and then 2 decimal places. See? Yeah. Parang ang konti naman. 4 na lang. There you go. Okay? So what are these, class? Ito na, class, yung ito na yung log returns. Okay? How did we do that? We got the log first, and then we got the difference. So here below, class, tingnan nyo. Okay, let's now get the log returns, class, using this function. So we're creating this object log returns is equal to the log of prices, and we can get the differences. And then we're going to create a table class. Create tayo ng object log returns data frame. Yung first column is period, paste 0. Period from 1 up to 11. And then a variable called log returns, which is equal to the log returns here. Okay. Sige, I'll give you a few minutes to run this. If you run this, class, ganitong mangyayari niyan. I'll give you a few minutes, class, and then kindly chat in the chat box if you're done. Thank you, Paula. Let's wait for the others. Okay, thank you, Adriel, Ariel, Aidan, thank you. Dean, thank you. Few more seconds for the others to follow. Okay, thank you, Moises. All right, I hope the others are able to follow. So we computed log returns class using the function difflog. But of course, we can compute it using ah okay. So we have computed for the simple returns. We have computed for the log returns. Now let's compute for the cumulative returns. Okay, from what we learned, class, when we're doing multi-period or when we're adding all the returns, if it's simple returns, the formula is 1 plus the return at period 1 multiplied by 1 plus the return at period 2, etc. up to the last period. Here, in this case, return at period 11, and then subtract minus 1. Now, we can make use of this function, prod. Okay, this is product class. And then let's use this name, cumulative simple returns. And we're getting the product, okay, the product of each of them. So 1 plus simple returns. Remember your simple returns is, where's your simple returns? Okay, nabura ko na, no? Print ko lang simple returns, simple underscore returns. Simple returns, ito siya. Okay, these were our simple returns. So what will happen here is that it will multiply product 1 plus this one, okay, and then multiplied by 1 plus this one, 1 plus this one, each of this class until the 11th period, 1 plus this one. Okay, so this is what it will do, and then subtract 1. And then let's just print out, concatenate cumulative simple returns, period 1 to period 11, and then include, comma, concatenate this one, the computation of cumulative simple returns, this one. Whatever is computed here, it will be included here. Okay, round off natin, convert natin into percentage and then decimal. Okay, so cumulative simple returns, period 1 to period 11, 7%. Okay, let's wait for your classmates to do this function. And if you're done, kindly please chat in the chat box below. Let's wait for everyone. Waiting. 7%. So the cumulative simple returns is 7%. How was it computed? 1 plus this one times 1 plus this one times 1 plus this one. 1 times 1 plus each of the individual simple returns, and then multiply it to all of them, and then subtract 1. Waiting for you to confirm that you were able to get it. Okay, thank you, Paula. 7%, you're correct. Yes. Okay. Cumulative returns of this class, 7%. Cumulative simple returns, ha? Kasi iba yung cumulative log returns. How about the others, please? Waiting for the others to give their feedback. Okay, Andrea, thank you. Okay, Adrian, good. Okay, keep them coming, please. Aiden, thank you. Few more seconds. All right. Okay, but I hope the others are able to follow. If you have any questions, please feel free to interrupt me and raise your hand so that I can address your question. All right. So we can actually compute it another way, class. Okay, because this one is just adding up. Okay, our simple returns. When I say add up, we're getting the product, right? Because that's how you cumulate simple returns. So what's happening here is that, okay, let me once again get the prices. Okay, these are the prices, class. So what we did was to get the simple returns of each and then get the sum of that. But when I say sum cumulative, we're using the product, right? So to check if that's realistic, what we can do is just get the beginning price and then the last price. So we get the returns 107 up to 100. And let's see if based on this number of periods, let's see if what we'll be getting is the same as 100%. So how do we do that, class? How do we do that? This one. Okay. So actual simple return. Okay. So we're not getting the daily returns. We're getting the the total already, the cumulative returns by getting the. So this is 12 class, diba? Length of prices. I'm getting the price at day 12, which is 107, divided by the price on day 1, which is 100, and then minus 1. And then print actual simple return from day 12 to day 1, okay? And I'm going to print the actual simple return multiplied by 100, 2 decimal places, and end there. All right, can you please run this, class, and tell me if it's the same as getting this, adding all the adding all the daily returns through the formula, the product, or it's just the same as getting the initial and then the the final and then the initial. Okay, please kindly confirm, class. I'm going to give you once again a few minutes to do that. Get the actual last day price divided by the last day, the actual first day price. And let's see what happens. I'm waiting for the first chat. Still no answer? Great. Thank you, Andrea. Thank you, Aidan. Thank you, Paula, and the others, I hope. Okay. Thank you, Dean. All right. So once again, class, I hope the others are able to follow. And if you have any questions, feel free to ask them. Okay. So we were able to show that indeed getting the cumulative returns using the formula and just comparing the last price with the first price, you'll get the same answer. Now let's cumulate let's cumulate the log returns. We already have the object log returns. So to get the cumulative returns, we'll just sum them up. Diba? Kasi R1 plus R2 plus R3 lang yan. No? And then once again, we get the printout of the cumulative log returns, the summary of daily log returns. Let's convert it into percent for decimal places, then end it here. Okay, once again, class, I'll give you a few minutes, a few seconds, please. Kopyahin nyo lang yung iba, class, as baguhin nyo na lang yung, yung mga names ng iba, no? Okay, and hopefully you'll get this, 6.7659. And we're expecting a return, cumulative return, lower than the simple return. Because we discussed that already before that your log returns will generally be lower than your simple returns. Unless they're very, very small, okay? And where we said that if the returns are very, very small, then your log returns and your simple returns will be approximately equal. Okay, class? Feedback again, please. Okay, good. Thank you. Okay, I noticed same lang yung nag-answer. I hope the others will also participate. Some of you, class, to be honest, I haven't seen you respond. And I know who are responding, no? So for some of you have been quite timid and have not even participated. I notice who you are. So please, magparamdam kayo, class, no? Kasi alam ko yan sa pangalan, nakikita ko eh. Okay, thank you. All right. So we can do it another way, class. Diba? Ito. Same thing with this one. You get the price at the end of the series and then divided by the price at the end of the series. So dito naman, class, same thing. We get the price at the end of the time series of the 12th day divided by the first day and then get the log. Kasi that's the formula for log, class. log of P sub t over P sub t minus 1, where your P sub t here is the price at time 12, okay, day 12, divided by the price at day 1. And you notice that the cumulative return will be the same. It will still be 6.7659 compared to getting the sum of the log returns. Okay, so I'll not discuss this anymore. I just use the log of P sub t over P sub t minus 1. Okay, so let's go here, class, and then let's see. Let's convert your cumulative return. Okay, our cumulative return is 6.7659. So let's convert it into so we're getting the simple return from the log returns. And you know that the formula is e to the rt minus 1, right? So we're getting the simple returns using the log returns. So it's equal to the exp exp exponent to the cumulative log returns. Okay, we're using the cumulative log returns here. And then minus 1. We expect this to be 7% class. Okay, kasi we computed the returns already using the same prices for using simple returns and log returns. The simple returns was 7%, the log returns was 6.7659. So when you convert this 6.7659, you have to get 7%. And using the e to the rt minus 1, you'll get 7%. Okay, I will leave you, class, to do this. You can just maybe take a photo of this, okay, and then transfer it to the code to your R markdown. And on the other hand, if you're getting the log from simple, the cumulative simple return is 7%. Okay, and then we expect the answer to be 6.7659. Okay, so if I run this, class, okay, simple return derived from cumulative log return is 7%. Log return derived from cumulative simple return is 6.7659%. Okay. You can see the percentage here sa dulo, no? And this means end. Kung may idadagdag pa, next line na yun. /n. Okay, so any questions, class? Any questions so that we can go to the next lesson? Clear so far? Okay, kindly chat, please, if you're able to follow. Okay, thank you, Paula. How about the others? Okay, Adrian, thank you. Yeah, thank you, Moises. Okay, Jello, Aiden. Thank you so much, class. Kian, all right, good. Salamat, but I hope next time I hope everybody will respond. Okay, so let's now go to the use of packages in order to compute returns. Kasi so far, what we have done was to manually compute for the returns, no? Using P sub t over P sub t minus 1, using log of P sub t over P sub t minus 1, when there are packages that can compute this for us. So we're going to load Quantmod and PerformanceAnalytics. Okay, so make sure that your Pacman package is loaded, because as I said a while ago, Pacman is such a helpful package, Pacman. Okay, in my case, it's not yet loaded. I'll check it here. Okay, so once I have loaded Pacman, I can now make use of this function, Pacman double colon, and this simply means that this function p underscore load, package load, is from the Pacman package. And then I'm going to load both Quantmod and PerformanceAnalytics. So the good thing about this is that you don't need to install Quantmod and install PerformanceAnalytics and then require it or library it. Pwede nang diretso na dito. Okay? If you check, paki-check class kung may Quantmod kayo. Have you loaded this last time? Hindi pa yata, no? Check kung may Quantmod kayo, class. Kindly check. If none, class, if none, you can make use of this. Kasi automatically this will install and load. Meron, yes, thank you, Paolo. How about the others? Meron ba kayong Quantmod? Those of you who are my students last time, I'm sure meron kayo niyan. Yung iba, okay, Andrea, meron din. How about the others? Yes, Jello, thank you. Meron bang may no, class? Meron bang may no? Wala, thank you. Okay, so Ariel, thank you. So in that case, Ariel, make sure that your Pacman is libraried, no? And then you can make use of this package. What will happen is that it will install Quantmod and then library it at the same time. In my case, may Quantmod na ako eh. Pero pag rinan ko tong Pacman payload Quantmod, it will load this package. I'll run this. Okay, tingnan nyo, nag-check na siya dito. No? Nag-check siya. So I used Pacman payload, which will install and load the packages at the same time. All right, so let's go here, class. I hope you have already loaded Quantmod. Quantmod is a very, very important package. Let's seek help about Quantmod. Ito, no? Here. So go to packages, type Quantmod, and then click it. All right, then we have here some documentation about the package. This one will lead us to a description of the package. So this was built, date of publication, may bagong update na siya. It doesn't tell us when the package was initially created. Okay. Does it? Wala. Hindi eh. Package June 18. Okay. Ito yung latest publication. But yung original ano niya, publication hindi nakalagay. So ito depends. Ibig sabihin, when you load Quantmod, it will also load XTS, Zoo, technical trading rules and methods, curl and JSON-like. Okay, these are the other packages that come loaded with it. So when you load Quantmod, hindi mo na kailangan i-load sa XTS or Zoo or TTR or methods kasi automatically i-load na rin niya yan. Okay. So let me go back, and then what are the codes that so many class? Yan. Ito yung mga functionalities that you can use with Quantmod. A lot of them, class. You can do charting, chart series nila. Okay, you can we're going to focus, you can add class ito. We're going to discuss this in the future. You can add Bollinger Bands, mga plots to, no? Add exponential moving average, okay? Relative strength index, simple moving average, volume, etc. MACD, MACD, moving average, convergence, divergence, okay, MACD, all right, and a lot of other functionalities. What we're going to make use of is letter G, get symbols. Ito class, no? Get symbols here. Get symbols, merong get symbols that alpha vantage, get symbols that Fred, etc. Gagamitin mo natin generic na get symbols. No? Okay, so let's go here to our code. Okay, let me delete this first. Okay, all right, we're going to use the function get symbols. And we first identify the name of the stock, the ticker symbol. So si Apple class, AAPL ang ticker niya. It means that its ID in the stock exchange Nasdaq class is AAPL. So when you use this, alam ni R na ang gusto natin i-download si Apple. Source is equal to Yahoo. This is the default. You can use other sources like there's a database called Fred, which we're going to look into next time. Federal Reserve Economic Data, St. Louis to. Okay. So pwede rin tayong kumuha ng data dyan. Control Z. Okay. So, but the default is Yahoo, which means that if I don't include this class, if I remove this, it will still look for the data in Yahoo. And we know naman na not all data can be found in Yahoo. So si Yahoo, good lang yan for the stock prices. But for macroeconomic data like inflation, GDP, GNB, we can't use Yahoo kasi wala doon. Okay? Then you can define the start date, in this case, from 2020-01-01 up to here 2024-12-31. Now, if you don't specify this, magdi-default si ano, si R. It will get the data from 07, ang default nito, 2007-01-01. This is the default. Which means if you don't identify yung from, okay, ito yung kukunin niya from January 1, 2007. Tapos ito naman until yung latest. Yung latest, yung most current. So the latest was, so ngayon sa US, tapos na yung, yung trading. So that will be September 15. Ibibigay niya September 15. Okay? So if you don't specify, ito yung magiging default lagi. Kung may trading nung July 1, sorry, this should be July 1. Hindi, January 1. Tama. So kung walang trading nung January 1, then January 2 or 3. Basta yung first trading day nung January 2007. But in this case, we're defining, no? From 2020-01-01 up to 2024-12-31. Okay, if you're getting several prices, then magsisi ka dito. Concatenate, Apple, kunyari Meta, Facebook, yan. You can get several prices. Okay, but let's just use one muna, Apple. So I'm going to remove the C here. Okay, then comma dito. All right, how about this? Auto.assign class. Auto.assign, it means is equal to true. It means that it will create an object. And the name of the object will be the name of the ticker symbol. Yan. Okay, so let's run this class. Let's run this. Get symbols, Apple, Control Enter. You notice that it will print the name here, Apple, there. And then if you check your data, magkakaroon tayo ng Apple na object ito class here. So it's an XTS object from 2001-02, ibig sabihin January 2, kasi walang trading ng January 1, hanggang 2024-12-31. And if we print this class, click this one, view natin, ito. We have here an OHLC object, open, high, low, close, volume, and adjusted. So starting with January 2, bakit walang January 1? Kasi walang trading ng January 1. Hanggang December 30, but walang December 31. That's what we identified. Yeah, there's no January 31 because there was no trading on December 31. So it ended in December 30. Okay?
Siya tapos na,
All right. So now, can you give it another name? Yes, you can. So for example, I want to give it a different name. Let's say AAPL. Small letters, it's different, no? Alt minus. All right. Maybe AAPL only. Small letters of the ticker symbol. If you want this class, you have to change this. Auto.assign is equal to false. So that R will not give automatically the name AAPL, capital AAPL, but rather create this object that you're designating this stock prices with. Okay? So if I run this class, what do you have? I now created an object called AAPL. And it's exactly the same as your capital AAPL, only they have different names. Okay? So if you want to give it a different name, then identify the name, and then auto.assign is equal to false. Okay. Let me just illustrate this. Okay. I'll delete I'll delete this class. I'll comment it out. Okay. Yung from at saka yung to. And then let's give it a name Apple1. So we're creating this object Apple1, and I'm not defining the from at saka the to, the start date and the end date. Let's see what happens if we run this. Control Enter. All right, then we have now here in our environment Apple1. Apple1. There you go. And then take note class here. It started with 2007, January 3, the beginning of the trading day of 2007. And then up to the, I said, diba? September 15 here. So if we print this, this is Apple1, and it starts at January 3 and ends at September 15. So it's a different object. It has more observations, 4,700 observations. Okay, so just so you know, class, about this. No? Okay, so I'll delete this. Okay, and then put back the Apple object. Okay, once again, if you don't want to name it small AAPL, just name it capital AAPL, then just use this. You can skip this. You don't have to write it because that's the default. Auto.assign is equal to true. If I didn't use that, then it will name it as capital AAPL, the ticker symbol. Okay. So our object AAPL has 6 columns: open, high, low, close, and then volume, and then adjusted. Now, if I'm interested only in getting one, let's say I'm only interested in getting the adjusted, Apple adjusted. Here. It's very easy, class, because you can use the dollar sign. So here I'm creating an object called Apple adjusted close, and then it's from Apple. Okay. If you see, if I type this, class, Apple. So since this is existing dollar, it will give us what are the columns, variables under Apple. And I want this adjusted. Okay. Down arrow and then adjusted tab. There you go. If I run this class, we will now have an object called Apple adjusted close here. And then if I print this, only the adjusted price. Okay. Only the adjusted price. All right.
Kailan mga signages, kailan mga point of purchase material, mga structure.
Drix, ano kita, mute kita, Drix, ha? Drix, please.
Ano siya? Factory.
Drix, imi-mute kita, Drix, ha?
Yes, sir. What we do.
Okay. All right, so let's now go here, class. Okay, so we already have this object, either the Apple object, or we have also this object Apple adjusted close, just one column. Okay, so when we're using Quantmod and when we're getting the returns, you can only use it for a univariate time series. So we will not use this, class. I'm sorry. We will not use this kasi maraming ano siya, no, maraming columns. Gagamitin natin, we're going to use the Quantmod function for daily returns and use it only for a univariate, only one column here. Okay, so let's take a look at the function now. Take a look at this, class. So let's calculate simple returns. But this time we're not going to manually create P sub t over P sub t minus 1 minus 1. Okay, so Apple simple returns, and let's use Quantmod. So sorry for the long name. It's just to make us know that this is coming from, we're using Quantmod, class. Daily return. So Quantmod has this function called daily return. In fact, you can put it this way, okay? So that we know that this is coming from Quantmod, daily return. And then notice I'm using Apple adjusted close. If I use Apple class, so let me just copy this, Control C, and then here, Control V. Okay, and then I'll just use the Apple object. The Apple object has 6 variables class, diba? Here, take a look at this. Let's use daily return on the Apple object. Control Enter. Okay, and then what do we have? Apple simple return quant mode. Here. Okay, what do you have? What is this class? Apple simple return quant mode. Asan na siya? Wait. Did I run it correctly? Or am I? Here. Here class, no? I use it for Apple. However, yung object natin, why only one column? Okay, and what was used, class? What was used? Is it the open price? Loading slowly. Okay. Is it the opening price? If it's the opening price, then this will be Control C divided by this one. .003. Okay. 0.003. This one is, how about the returns? 0.001, 0.01. Okay, so it's not the opening price. So we don't know, class. We don't know. Okay, so, and also, if I want to get the daily returns of all of this, except for the volume, and maybe for the volume, then we can choose the daily return, because the daily return is only used for univariate, just a single price. Okay, so let me go here again. Where am I? Okay, here, class. So we're using this class for for an object that's univariate. Apple adjusted close is only one column. That's adjusted price. So we can make use of the daily return for that. Okay, so let's run this. Control Enter. And then Apple simple returns quant mode. It's this one. So we have this one class. Take note, the first column, the first row is 0, 0, 0, 0. The second row is negative 0.009 something. Okay, so how did that go? Because it's based here. The first one is 0, class, because this has no prior value. And then if you perform 71.8331 divided by 72.5 something, then that should be a negative, class. Kasi -1 yun, ano? And then just spot check, negative, no? Negative. So our function, si Quantmod, using daily return, was able to compute all the returns, class, for this object, Apple adjusted close. Okay, so this is the object, daily dot returns. Let's change the name, class. How do you change the name? Let's make it so column names of this object, let's name it apple.simple.return. Okay, so you can run this and it will change the name of this daily returns. No? So ito na lang. There. And then we can check the head, the first 6 observation. Ayan. Andun na yung pangalan na apple.simple.return. So it's almost time. I'll just, class, I'll just discuss this quickly. But if you need to go, you may do so. I'll just, to class, no? There's another package class, yung performance analytics. We can use this return.calculate. Okay? Return.calculate on the same object. So Apple simple returns performance analytics. Okay, let's see. Let's run this. I'm sorry. Control Enter. Apple simple returns PA. Then take note class may NA dito. So there's a difference between the computation of Quantmod and performance analytics. See, performance analytics, it specifically tells us that this is NA. Why so? Because there's no prior value. You cannot compute the returns without any prior value. Okay, so we can just also, the name is Apple adjusted. It's not Apple adjusted, but it's Apple AAPL dot simple return dot performance analytics, maybe that one. And let's print this. Okay. You have an NA here. Okay. All right. So next meeting class, we'll just quickly compare. Okay. And then we'll go deeper into the computation. Okay. And then once again, we have here some formulas. Okay. We're going back briefly to descriptive statistics with the end goal of the end goal class is this is a topic on descriptive financial analytics. So we'll be studying descriptive statistics also, mean, median, mode, etc., variance, standard deviation. By way of review, measures of skewness, measures of spread, skewness, kurtosis, etc. Okay. And then we will learn how to visualize using histograms, using candlestick, etc. And the end goal is at the end of this, we should have learned how to create portfolio returns also and portfolio standard deviation. So this one we're going to discuss. Hopefully next meeting class, hopefully we'll be able to finish this one. It's a tall order. It's a ambitious goal, but we can do it. Okay, so let me stop recording now.